In this video, we're going to talk about properties of rectangles, and I'm sure you have learned about rectangles many years ago, so you already know a lot of these properties. We're just going to add in a couple more geometric properties to help us solve some problems. So first of all, the definition of a rectangle is a parallelogram with 4 right angles. So we just spent a lot of time talking about parallelograms. Now we are taking that same shape, and now we know a rectangle just has 4 right angles. So these first 4 properties of a rectangle are the same 4 properties of a parallelogram. So if it was true in a parallelogram, it's true in a rectangle. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary, and diagonals bisect each other. So we can mark up our picture with congruent and parallel symbols because I know those opposite sides are congruent and parallel per property number 1. Opposite angles are congruent. Well, that makes sense because we know all of the angles are right angles. So if one of them's a right angle, the other one's a right angle. And consecutive angles are also supplementary, so these still do add up to 180 degrees, right? All 4 all around the sides are supplementary. 90 plus 90 is 180. And the diagonals bisect each other. Now there's 2 more unique properties. The first one is that all 4 angles are right angles. That's part of the definition. That's part of what makes a rectangle a rectangle. And now the second one is that now my diagonals are actually congruent. Because my parallelogram kind of straightened up, this entire diagonal, this entire diagonal here is going to be congruent to this entire diagonal here, whereas in our parallelogram they were not congruent. But we can kind of easily see and assume that those 2 look to be the exact same length. So diagonals are congruent and diagonals bisect each other. So we knew in a parallelogram that those 2 pieces would be congruent to each other. Well, now actually we know all 4 pieces are congruent to each other because the entire big diagonals are also congruent. So the only thing that we added in there really are the right angles, and the diagonals themselves are congruent. So we're going to use these same properties to help us solve some problems. So let's go on to example number 1. So again, even if it doesn't ask us to state the if-then statement, we still want to be able to look at our problem and determine the property that we know. So in this one, we're given that we want to find this angle in rectangle T, and we know the property of rectangles very well, that all angles of a rectangle are right angles. So that means that this angle down here is a right angle, meaning it's 90 degrees. So we can set up the equation 5x plus 18 is equal to 90. And we can solve. Subtract 18 from both sides. Divide both sides by 5. So we get x to equal 14.4. That was nothing new. We probably could have done that a while ago, a couple years ago, maybe even. In example number 2, again, we have a rectangle ABCD, and in this one, we're given the measure of angle BAD is 5x, so that's this angle down here, BAD, and segment BC is 2x minus 9, and segment AD is y plus 4. So we can look at 2 different properties here. One, we are given angle A is 5x, and we know that all angles of a rectangle are right angles. So we know that 5x is equal to 90. And we also are given 2 side lengths, right? We're given the top and the bottom side length. So I know in a rectangle, that opposite sides are congruent. So I can write the equation, this 2x minus 9 is equal to y plus 4. But I can't solve that equation on the right yet because I have an x value and a y value. I first have to find x. in order to solve. We have to find x first, which is easy to do. I'm going to divide both sides by 5. So we get x to equal 18. And now I can take that 18 and I can use it in my equation. Now I actually know how big that side length is. I know that 2 times 18 minus 9 would get me to 27. So I know this top segment is 27. I know that bottom segment also has to be 27. So if I subtract 4 from both sides, we get y to equal 23. Okay. Last example we're going to do together. We have, again, a rectangle talk. We know TL, which is this entire diagonal. That entire diagonal is 6y minus 10. And KA, which is this entire diagonal, is 5y plus 1. So we want to find y. Well, since we're given that both of those two are diagonals in a rectangle, we know the property that we just talked about above is that in a rectangle, diagonals are congruent. So I know that 6y minus 10 is going to equal 5y plus 1. So we can get our y's to be on the same side and add 10 to both sides. So we get y to equal 11. So those were some examples of using properties of rectangles. Please make sure you have those properties from the beginning of the video written down. Go ahead and turn the page. There's a few in-class practice problems and review problems. When you are finished, check in with your teacher. Thanks.